my channel STEM Cafe. Here we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. Today we'd like to treat some questions under power series. Well, before we go on to answer some questions to make our work easier, I would like to highlight some of the series we have already established, or the ones that are already established. Simple. So that we build our work based on the established ones. So if you believe that this topic will be useful for you, I'd rather you copy this out in a notebook and learn them, or find a way to recall them anytime you need them. E raised to power x, we all know the natural number. The expansion is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and continue like that to x raised to power n over n factorial for all values of x. E raised to power minus x, that is 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x raised to power 4 over 4 factorial, and continue like that to minus 1 raised to power n minus 1 multiplied by x raised to power n over n factorial for all values of x. For sin x, we have derived this before. X minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial, and continue like that. Every term will be minus 1 raised to power n times x raised to power 2n plus 1 over 2n plus 1 factorial for all values of x. Cos x will be 1 minus x squared over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power 6 over 6 factorial plus x raised to power 8 over 8 factorial. So minus 1 raised to power n multiplied by x raised to power 2n over 2n factorial for all values of x. Sin x will be x plus x cubed over 3 factorial plus x raised to power 5 over 5 factorial plus x raised to power 7 over 7 factorial, and continue like that to x raised to power 2n plus 1 over 2n plus 1 factorial for all values of x. Cos x is 1 plus x squared over 2 factorial plus x raised to power 4 over 4 factorial plus x raised to power 6 over 6 factorial, and continue like that to x raised to power 2n over 2n factorial for all values of x. For tan x, we have x plus x cubed over 3 plus 2x raised to power 5 over 15, and continues like that. Arc tan x is going to be x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial, and it will continue like that. So tan x is equals x plus x cubed over 3 plus 2x raised to power 5 over 15 plus, and continue like that. Arc tan x is x minus x cubed over 3 plus x raised to power 5 over 5 minus x raised to power 7 over 7, and continues to minus 1 into n raised to power minus 1 multiplied by x raised to power n over n. And sin square x is x squared minus x raised to power 4 over 3 plus 2x raised to power 6 over 45, and continues like that. Now, for ln 1 plus x is going to give us x minus x squared over 2 plus x cubed over 3 to minus 1 raised to power n minus 1 multiplied by x raised to power n over n for minus 1 less than x less than and equal to 1. For 1 plus x raised to power n, this is very interesting. This we have it as 1 plus nx plus n into n minus 1 over 2 factorial x squared plus n into n minus 1 into n minus 2 over 3 factorial x cubed plus, and continues like that. For minus 1 is less than x, and x is less than 1. For 1 minus x raised to power n is going to be 1 minus nx plus n into n minus 1 over 2 factorial x squared minus n into n minus 1 multiplied by n minus 2 over 3 factorial x cubed, and continues like that. This series is valid for when x is 1 minus 1 is less than x and x is less than 1. So from this 1 plus x raised to power n and then 1 minus x raised to power n, that is like binomial expansion, we can derive 1 plus x raised to power minus 1, 1 minus x raised to power minus 1 easily. We can also derive 1 plus x raised to power minus 2 and 1 minus x raised to power minus 2, 1 minus x raised to power minus 3, and 1 minus x raised to power minus half. So let's look at each. So for 1 plus x raised to power minus 1, we are going to have 1 minus x plus x squared minus x cubed, and continues like that. Remember, for minus 1 is less than x and x is less than 1. 1 minus x raised to power minus 1 is going to give us 1 minus 1 is lesser than x and x lesser than 1. For 1 plus x raised to the power minus 2, we have 1 minus 2x plus 3x squared minus 4x cubed plus, and continue like that. For minus 1 is less than x and x lesser than 1. For 1 minus x raised to the power minus 2, please note, 1 minus x raised to the power minus 2. That's going to give us 1 plus 2x plus 3x squared plus 4x cubed, and continue like that. Remember, minus 1 is lesser than x and x is lesser than 1. For 1 minus x raised to the power minus 3, we are going to have 1 plus 3x plus 6x squared plus 10x cubed. If you continue, you can guess what the series will be like. The next one will be maybe 15x raised to the power 4, and continues like that. For minus 1 is lesser than x is lesser than 1. For 1 minus x raised to the power minus half, this one is also very useful. We are going to have 1 plus half x plus 1 times 3 over 2 times 4x squared plus 1 times 3 times 5 over 2 times 4 times 6x cubed, and it continue like that, please. So you can see, for 1 minus x raised to the power minus half, we are going to have 1 plus half x plus 1 times 3 over 2 times 4x squared plus 1 times 3 times 5 over 2 times 4 times 6x cubed plus, and continues like that. You can easily guess the next term. So these are the few examples that we have derived, and they will be very useful for us in working out some questions. So let's go to the questions, and I believe for each you will find them easy to solve without wasting of time. Now, with the established series, we can easily solve some questions, and even if we need to do some expansion, it won't be that tough since we have the knowledge or basic knowledge of how to get the series in the first place. Now let's look at this question. It says, show that if x is small, sin square x minus x squared cos x over x is equal to 1 over 6 plus x squared over 360 approximately. Let's see how we solve this. Now let's look at the way it's solved. We first of all, enumerate sin square x. The term for, the series for sin square x, and that is x squared minus x raised to the power 4 over 3 plus 2x raised to the power 6 over 45, and continues like that. Then it's factorized at the end. So we have x squared into 1 minus x squared over 3 plus 2x raised to the power 4 over 45, and continues. For x squared multiplied by cos x, we now put x squared in front of the expansion for cos x. And expansion for cos x is 1 minus x squared over 2 factorial plus x raised to the power 4 over 4 factorial, and continues like that. So at the end, we have in brackets x squared into 1 minus x squared over 2 plus x raised to the power 4 over 24, and then continues. So here, we did the subtraction. And since they have the common factor x squared, that is left outside, so we now put the others into brackets. We have 1 minus x squared over 3 plus x raised to 2x raised to the power 4 over 45 minus brackets 1 minus x raised to the power 2 over 2 plus x raised to the power 4 over 24, and continues like that. So at the end of the day, the subtraction is done. So we have x squared outside, and then 1 minus 1 minus x squared over 3 plus, because minus times minus in the second bracket gives plus. So we have x squared over 2 plus 2x raised to the power 4 over 45 minus x raised to the power 4 over 24. And then, at the end of the day, we have x squared multiplied by brackets x raised to the power 2 over 6 plus x raised to the power 4 over 360. So the next step will be to divide our answer by x raised to the power 4. Now, from here, you can see that there are still some other terms behind the x raised to the power 4 over 360. So from here, we factorize further, because x squared is common term. So we have x squared multiplied by x squared into 1 over 6 plus x squared over 360, and the term continues. So at the end of the day, we have x raised to the power 4 plus x raised to the power 4 into 1 over 6 plus x squared over 360. Surely the term continues. At the end of the day, we have to divide by x raised to the power 4 to get our final answer. So we have sin square x minus x squared cos x over x raised to the power 4. So since we have this as the answer for sin square x minus x squared over cos x squared cos x, so x raised to the power 4 cancel x raised to the power 4. So we have 1 over 6 plus x squared over 360 with the term continuous. So at the end of the day, we have approximately 1 over 6 plus x squared over 360, since x is very small. So the other terms will not really have much role to play, because of the power of x. X is small. So by the time the power is increasing, the value of x will be getting insignificant. Now we have this. It says take the series for ln 1 plus x. If 1 plus x equals b over a, show that b squared minus a squared over 2ab equals x minus x squared over 2 plus x cubed over and continues like that. And show that if b is nearly equal to a, then b squared minus a squared over 2ab exceeds ln b over a by approximately b minus a cubed, b minus a bracket cubed over 6a cubed. Now let's see how we tackle this. Now the first part asks us to state the series for ln 1 plus x, and that is x minus x squared over 2 plus x cubed over 3 minus x raised to the power 4 over 4 plus and continues like that. And please take note, we know that 1 plus x is equal to b over a. So from there, we'll be able to solve the next part. Now, the second part is telling us that 1 plus x equals to b over a. And it's now asking us to show that b squared minus a squared over 2ab is equal to x minus x squared over 2 plus x cubed over 3. So we can see that b squared minus a squared over 2ab is equal to b squared over 2ab minus a squared over 2ab. So if we, process that, we are going to have b over 2a minus a over 2b. Now that brings us to this place. And that is half into b over a minus a over b, which equals to half into 1 plus x minus bracket 1 plus x raised to power minus 1. That is the reciprocal of 1 plus x. Since b over a is equal to 1 plus x, so a over b will be 1 minus, will be 1 over b over a, and that is b over a raised to power minus 1. So that one is solved. Now, we also have expansion for 1 plus x raised to power minus 1. Remember, and that will be 1 minus nx, okay, 1 minus x plus, so remember we have expansion for 1 plus x raised to power minus 1, and that is 1 minus x plus x squared minus x cubed, and continues like that. So with that, we can easily solve this part. Let's see. So you can see this part from binomial expansion, we have been able to get that one. So we now have 1 plus x, that is that part, minus this part. So on solving this, 1 cancels 1, and x plus x equals 2x, and the other ones, the signs change. The signs change. So we have half into 2x minus x squared plus x cubed minus, and it goes on. So on dividing everything by 2, we have x minus x squared over 2 plus x cubed over 3, and it goes on. So we have been able to solve this other part. B squared minus a squared over 2ab is equal to x minus x squared over 2 plus x cubed over 2. So the last part is now asking us that if x is very close to a, that is, the difference is very small. That is, the difference between b squared minus a squared over 2ab and ln b over a will be very small, and will be approximately b squared, b minus a all cubed over 6a cubed. So let's see how we work that out. Now let's see the difference between b squared over a. Let's see the difference between b squared minus a squared over 2ab minus ln b over a. We have established that b squared over a squared over 2ab is x minus x squared over 2 plus x cubed over 2, and goes on like that. And ln b over a being ln 1 plus x is going to give us x minus x squared over 2 plus x cubed over 3 minus x raised to power 4, and continues like that. So b squared minus a squared over 2ab minus ln b over a is going to give us x minus x squared over 2 plus x cubed over 2 minus x minus bracket x minus x squared over 2 plus x cubed over 3, continues like that, all into brackets. So let's solve this part and see what it gives us. So you can see from here, b squared minus a squared over 2ab minus ln b over a is approximately x cubed over 2 minus x cubed over 3. And since x is very small, when b is close to a, so we have this, approximately this, because the value of x will be very small. All other powers will be very insignificant. And we have also noted that b over a is equal to 1 plus x. So x equals to b over a minus 1, which is b minus a over a. Now let's work it out. So from here, we can see x squared minus over 2 minus x cubed over 3 is giving us x cubed over 6. And we know that x equals to b minus a over a. So if you cube x cube b minus a over a, it's going to give you b minus a cubed over a cubed. So at the end, our answer is going to be b minus a cubed over 6a cubed. So you can see that the difference between b squared minus a squared over 2ab and ln b over a is approximately 6 minus a all cubed over 6a cubed. It's approximately b minus a all cubed over 6a cubed because x is very small. That is, the difference between b and a is very, very small. Use the expansion of cos x and 1 over 1 plus x to show that cos x over 1 plus x is equal to 1 minus x plus x squared over 2 minus x cubed over 3 plus 13x raised to the power 4 over 24 and continues like that. Now let's see how it's solved easily. So our step will be to state out the series for cos x and 1 plus x raised to the power minus 1, and we multiply the two. Let's see how it's done. Now, cos x is equal to 1 minus x squared over 2 factorial plus x raised to the power 4 over 4 factorial, and continues like that, which equal to 1 minus x squared over 2 plus x raised to the power 4 over 24 and goes on like that. So the other ones are insignificant. 1 over 1 plus x is equal to 1 plus x raised to the power minus 1, and that gives 1 minus x plus x squared minus x cubed plus x raised to the power 4 and continues like that. So cos x over 1 plus x is equal to cos x multiplied by, so cos x over 1 plus x is equal to cos x multiplied by 1 plus x raised to the power minus 1. And let's do the multiplication. So now look at how I multiplied the two out. This is for cos x, and this is for 1 plus x raised to the power minus 1, this part. Now, so I'm multiplying it out. I want you to study the table just for like a minute, because the terms that are necessary for me, because of the answers given, are the terms up to x raised to the power 4. So I will extract that out. So from here I have 1 x minus x squared, x cubed. So x raised to the power 4 is there, x raised to the power 4 is there, so x raised to the power 4 is there. So those are the ones that matters to me. So you can see, I brought out the terms of x squared, x cubed, x raised to the power 4. So that is the answer. You can see, very easy and straight to the point. Now let's work this. It says, by the use of Maclaurin series, show that arc sin x equals to x plus x cubed over 6 plus 3x raised to the power 5 over 40 plus, and continues like that. And we know by Maclaurin series from power series, it's going to be like this. So it's going to be fx is fo plus f first differential multiplied by x, second differential multiplied by x squared over 2 factorial, third differential multiplied by x cubed over 3 factorial, and continues like that. So let's start. Let's find the coefficients first, or the f's. Let's find those ones first. Now, you have now expressed 1 over root of 1 minus x squared in power series. And that gives us 1 plus x squared over 2 plus 3 over 8 x raised to the power 4 plus 5 over 16 x raised to the power 6 plus 35 over 128 x raised to the power 8 plus continues like that. So with this, the differentiation, further differentiation will be very easy to handle. Now let's go on to the next one. So, on differentiating this, I got this. So f2, 0 gives us 0. Now let's go to the third one. So we have to differentiate this to get the third one. So f. So after differentiating and slotting in the value of 0 there, the third differential gives 1. Let's get the fourth one. can see, on differentiating this is the answer. So slotting in 0, f0 is 0. So now, on differentiating f4x, I got it. So on slotting in 0, I got 9. On differentiating f4x, I got 9 plus 225 over 2x squared plus. So I got this expression. So on slotting in 0, f50, I got 9. So let us now put this into our Maclaurin series and see what that gives us. So those are the values of our f that we will be slotting to get our coefficients. So on slotting them in, f0 is 0, 1 there, f3 is 0, f4 is 0, f1 is 1, f2 is 0, f3 is 1, f4 is 0, f5 is 9. So on slotting them in, you can see all these other ones cancel, those zeros. And then I have 9 over 5 factorial, which is 9 over 120. And that is 3 over 40. So you can see it's the same thing with the answer given in the question. So that one is solved. So the question states, find the first 4 terms in the expansion of x minus 3 divided by bracket 1 minus x bracket all squared multiplied by bracket 2 plus x squared all brackets in ascending powers of x. So let me rewrite it for clarity. So the expression can be written as x minus 3 multiplied by 1 minus x raised to power minus 2 multiplied by 2 plus x squared raised to power minus 1. So for ease, to handle this one easily, we have to express 1 minus x raised to power minus 2 in power series and 2 plus x squared raised to power minus 1 in power series. And then we multiply all the 3 to get the value we are looking for. Let's see how it goes. So the expansion for 1 minus x raised to power minus 2 is 1 plus 2x plus 3x squared plus 4x cubed plus, and goes on like that. For 2 plus x squared raised to power minus 1, because the number in front must be 1, I have to bring the 2 out. So I have 2 raised to power minus 1 into 1 plus x squared over 2 raised to power minus 1. So at the end of the day, I add half into 1 minus x squared over 2 plus x raised to power 4 over 4, and it goes on like that. So the expression x raised to power minus 3 over 1 minus x squared into 2 plus x squared bracket is going to be x minus 3 multiplied by 1 plus 2x plus 3x squared plus 4x cubed, goes on like that, multiplied by half into 1 minus x squared over 2 plus x raised to power 4 over 4, and goes on like that. So it makes our job very, very easy. So for me to get x raised to power minus 3 over 1 minus x all squared multiplied by 2 plus x squared, I will just take it in turns and multiply them one after the other. Let's see how it goes. So you can see x raised to power minus 3 into 1 minus x all squared to 2 plus x squared will be equal to half into x minus 3 to 1 plus 2x plus 3x squared plus 4x cubed into 1 minus x squared over 2 plus x raised to power 4 over 4, and goes on like that. So let me multiply the last 2 first, and then I multiply with the first one. Let's see how it goes. So to multiply the last 2 brackets, I have drawn the table. So let's see. So look at the table drawn. So it's for multiplication. So all I need to do is to gather the like terms, and the highest power I need is x raised to power 3, because they have said the first 4 terms. So the highest power I need is that of x raised to power 3. So let's gather it. So gathering the first 4 terms, 1 plus 2x plus 5 over 2x squared plus 3x cubed. This now I will multiply it with this, and then half it. So multiplying the last 2 with this first one, let's see what it will give us. So multiplying all the brackets out, leaving out the half, this is what it will give us. So let's collate the results. So on multiplying out, I got minus 3 minus 5x minus 11 over 2x squared minus 13 over 2x cubed, like that. But mind you, we still have half that we have not used to multiply the other results. So the total answer will be half of this answer gotten here. So let's see. So what this implies is that this half multiplied by all this is the answer, and this one gives us this. So at the end of the day, our answer is going to be half multiplied by this. So this is the answer to this. You can see the process we went through, and it's very easy and fast. So if there is any question, go to the description or through other channels provided in the description. You can also use the comment section for any suggestion or questions that needs to be answered. Thank you very much. See you in the next class.